All right. Okay, guys. My name is Ketan. I'm the CEO and co-founder at Union. At Union, we are an open core company. We have some interesting open source products used by thousands of companies worldwide, including companies from Stripe, Tesla, NVIDIA, Expedia, Spotify. All of them use our products to orchestrate machine learning and data processes at scale. And over the last few years, we've seen a huge demand from us for AI orchestration. And we've taken our unique capabilities and like kind of blending more for teams that want to move fast in the AI world. But we basically call ourselves an orchestration company. And the question is like, what is orchestration and how is it evolving? So let me go a little bit back in history for those of you who have not heard or are new to the term of orchestration. Orchestration is actually pretty much as old as software because orchestration means how things get done. Nobody really wants to write software that runs, in isolation. Software usually depends on data or sequencing from other software. And finally, nobody really wants to run that software on their own. So usually it deals with a lot of automation. And that's where orchestration comes in. Orchestration is the idea of sequencing software, moving data between things, and allowing automations to creep in. And if you go back in the history, we did this with things like scripting, make files, and a bunch of them. Eventually, in the 90s, came about was BPMN, business process automation. And then, we had enterprise beans, et cetera, like a bunch of different things in the 2000s. But really in 2010, when microservices and data started really taking hold, we started seeing orchestration in open source. And in 2012, ETL became the rage, and there were a bunch of open source orchestration solutions like Azkaban, Luigi, Airflow, and the like. I'm primarily focused on, ETL, where you have to move data from one farm to another. And as the microservices were taking hold, people were like, hey, we want to do Stripe payments, or we want to do automate how systems communicate to create an effective outcome. Like I was at Amazon for a long period. And in the early, this is like 2008, 9, 10 period, we already had the entire order pipeline was orchestrated by a workflow engine that was built in-house. Moreover, if you use S3, EC2, any of the other cloud services, they are all orchestrated underneath by orchestrators like step function, simple workflow, temporal, etc. But in 2017, I ended up at a company called Lyft, and we were a tiny team of like 50 engineers trying to grow, build a lot of AI into our software because we were a broker who wanted to bring efficiency into their product. And the way we did it is we were trying to ship a lot of different machine learning models. And with machine learning models came different people, different teams, like ML engineers, researchers, AI engineers, software engineers, data engineers, and came a huge challenge. They all needed different types of compute infrastructure. One big observation that I had during this period, and which still holds true, and I'll walk you through how that is that the way we've been building software is getting challenged. It was in 2017. And that's because software is designed on the principles of consistent evolution on the, a common set of known constraints, while ML and AI doesn't work like that. ML and AI always dynamically change, improve, alter their behavior based on environmental circumstances. And so you need a very different tight inner loop of trying out, like the regular ideas of unit testing and simple ways of deploying don't really work. You have to like test on real data, test on changes, do A/B test, do a lot of experiments, and finally take things out. So it becomes more research. And so the tool stack that we were building at that point was not really directly applicable to the ML world. So we started building a different tool stack. And this is what gave rise to an orchestration engine that we call Flight. And this is what's used by a lot of different companies. And in 2021, what we realized is that this movement is going to become even bigger. We saw AI was coming. So we formed a company, Union, to help many teams, reach this idea of iterating rapidly on research-like ideas and taking them to production. And over the last 2 years, after the ChatGPT boom and agents starting to take hold, we've realized that many people are now trying to build stochastic AI processes and take them to production, and we call them agents. And I was even recently telling people that it's not too different from a model. What's a model? Is ChatGPT the model, or is all the prompts added on top of ChatGPT the model that you're serving? And once you do that, you have to now start thinking about how do you experiment, how do you ship things to production, how do you change it? And this is where the last few years you've seen now a lot of different people saying AI orchestration is the biggest challenge. And the idea of getting things into production is very hard. Fixed paths don't work. So we took our understandings for the past 10 years of doing ML orchestration and applied to these questions from AI orchestration. And what we realized is, of course, this decides to load in a different way, that you cannot have a static orchestration graph. The entire idea of orchestration is changing. In the past, humans used to orchestrate. Now, models themselves orchestrate different processes. So you need a way to bring dynamism right at the core and allow it still to be secure, scalable, and independent. And once you have these processes in production, it's very hard to debug. And that's true even for any distributed system. Now think about these distributed systems that are dynamically created. So you need to detect failures, handle them dynamically, and alter the behavior. Or in some cases, failures are okay. Like being rate limited is okay. You should be able to handle that and potentially go to a different model. There are lots of limits of static execution. Like if you take an execution and if you think about plan it out like a regular piece of software, that's not how agents work. Agents have dynamic decisions and dynamic loops. They even may need dynamically to create new types of infrastructure. Like some of them may need GPUs, some of them may need sandboxes. And oftentimes, my idea, like many people see agents today as being in the forefront and you interacting. But if you really think over a long period, agents are going to be in the periphery and they're going to always exist as you work. So they need to be reliable in the back, but they also need to probably fan out and scale to massive amounts of compute. And they may come back and respond to you through notifications or like invocations when they need help. And then finally, when they're running in background, you cannot really tolerate failures. Like hopefully they can self-heal and improve and keep on going and solving their own problems. And then with all of this comes a different set of best practices. Like how do you build them? How do you test them? How do you ship them? What is the unit test for your changes in prompts? What are the unit tests for fine-tuning a model and so on? And so this is where we took the best of what we have been doing. We've been building this amazing, durable, resource-aware orchestration platform that was very geared toward taking stochastic ideas like ML processes into production. And we added a full dynamism to it to create one umbrella product that allows you to take your data, your AI models, as well manage your compute, which is very bespoke for these kind of systems. So I know this sounds very abstract. So what I'm going to do is I'm going to show you a quick demo. I don't know if I have enough time to go through a large demo, so I may go a little fast, but I'm happy to answer any questions and follow up. So let's jump into a demo here.
Ketan, don't go too fast.
Yeah, okay.
Don't go too fast. You're here. Let's give people the time to understand what you're doing. Otherwise, it's counterproductive. Okay,
Okay,
so don't go too
so
fast.
if that is the case, then I'm going to take a thing to explain how this modern orchestration works, right?
Yeah,
I'm gonna
please
write
do.
something from scratch, and we're going to try and see. And I know this is a little too deep in the code, but that's what we are dealing with. We are a code developer first platform. We are a platform for companies who are trying to build their agents. We are not an agent provider. Oftentimes people write code in Python, and a code in Python looks something like this. Let's say we want to do something simple, like I want to square 10 numbers. n numbers, right? So the way I will write it is like I'll write something like this. I want to square the numbers, and I'll take it's listening to me. It seems like it just said 10, and I want to generate the square of numbers. This looks something like this. A more typical way of writing this in Python would be to use map and square range n, and that actually doesn't return a list. So you have to convert it to a list. All right. I have this and I want to run this immediately. The way you do this is you write print and run. And of course, this decides to find a bug in my code or the generated code because Copilot is generating quite a bit of it. Yeah, so I was able to take a square of the numbers. This is, I know this idea looks very simple, but how do I take it to a distributed system from my laptop in a second? Because that's how I'm iterating. And that's where our open source product comes into play. You basically import one library, and then you can create an environment in the distributed system where you want this to run. We call it a task environment. You can give it a name. We call it square numbers. You can give it resources. You can even give it resources like, I want GPUs and I want A100s, one of them, or I want four of them. If you try to say nine of them, it already complains there is no machine that has nine A100s, 80 gigabytes on one box. So now I have created, I don't need GPUs for this example, thankfully. I don't want to burn that much money, but you can now create an environment and just apply this environment to each of your functions. And what ends up happening is if I just simply change my run command to be, I have a config to point to the remote, and I can simply run this guy using a simple modification to my code, which is at the bottom of my line. Well, let's run this and then I'll talk to it. Okay, so what it's going to do is going to see I need an image, a container image. I need an endpoint. I need to package this code, ship it to remote, bring up machines, apply the code, and run it. And this is a list of over n numbers. So it's going to apply one by one by one. If you know this is all sequential code, so it's going to run sequentially. And you'll see that it's actually running sequentially. It's dynamically scaling things and adding machines and squaring the numbers. This is pretty slow. So when you're running remote, you have one benefit. You're not limited to one machine. So let's actually abort this guy. You could have let it run, doesn't matter. But let's abort and just make it go parallel. By default, sequential Python cannot go parallel, but we ship with the entire system's async IO. So if you use async functions, you can dynamically go parallel. But if you're using synchronous functions, you can simply apply a couple changes, just like one flight.map. And what that does is immediately, actually, I should have shown this, just goes boom, 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 hundreds of machines are spun up. This can go up to like some of our customers are running on 25,000 GPUs and thousands of machines. And this just scales dynamically and you're already done squaring. That's the power of the platform, that you can take your ideas, isolate and run them in parallel as different people are working on it, because everything is versioned. So what these things are, these are the things that I was working on. They all get versioned. You can all see various versions of them. You can see all the executions that were running. Each execution that runs has its own set of permissions, secrets, runs all in a Kubernetes cluster in your cloud. It doesn't need to be anywhere else. We just can orchestrate and make them go really fast. To bring this point home, I'm gonna actually say why this is useful, and I have a couple of examples for agents. But let me show you one example. Which one was it? Maybe it was this one. Yeah. So what this allows you to do is actually I'm going to just jump and show code in the UI directly. So you can create agents, and agents are these dynamic entities, right? For example, a typical agent, and this is an agent I wanted to do, and you can look at the inputs of this agent. I wanted to give it a goal, and the goal that I gave it was make me a peanut butter jelly sandwich, or in this case, it was hello. Sure, I can change the to make me a peanut butter jelly sandwich. And what ends up happening is it tells me that you have to first create a plan, execute the plan, and then invoke the tools dynamically. These tools may have dependencies on each other. For example, you cannot spread peanut butter and jelly if you don't have bread and peanut butter. So you first go and buy the peanut butter jelly sandwich, buy the bread peanut butter, then you spread it. So let's read on it and you will see it live happening. And that's how you'll probably explains more. So what ends up happening is it plans, and then as the plan comes about, you start executing the plan. And if you start executing the plan, it's going to say like, yeah, I want you to run these 15 functions. It's going to find these functions. It's going to run them one by one. And eventually you can eat the sandwich. This is proverbial agent. This agent may crash randomly. You may have an out of memory. So how do you handle that? So in this case, this thing failed with an out of memory. You can actually handle the out of memory. And so if you go and see the inputs to this was, I was just running it on a 250 megabyte instance. I wanted to have more machine. So I just ran it with more, and you can immediately do it. And this can be done in the code simply by catching an exception that says, hey, I got an OOM. It's not just OOM. Now think about Spot Machine's availability, lack of resources for running a model. All of those things can be handled as errors, and you can react to them dynamically by changing resources or changing whatever. You can even ask an LLM to say, hey, I got this error. What should I do next? And it can tell you, why don't you increase the memory and try it out? And immediately it'll run it with that. And finally, just to nail this home, this is not just a toy. It can run real world examples, and one of them, of course, this one is a deep research example. And what we did is we actually took an open source agent that somebody had written for doing deep research. And what that deep research agent was using Together AI for the model and Tavily search. But it's a massive, large agent, and the goal of this one was, is the question. List essential requirements for a developer-focused agent orchestration platform, and you can directly evaluate and see how it's going through. How did it break down the research topics? And you can see the first set of topics that it came up with, and then for each one of them, it evaluated, did a search for all of them in parallel, and you can actually see inside a task, like as it was invoking the various models and so on, what the results were.
Hey,
And
Ketan, I've got the most basic question here, and
yes,
maybe other people have it online. Is so your this framework and Union works across clouds, or
yep.
at least for you maybe not across, but for most
No, it
clouds.
works across clouds.
It does
One
even work
step
for
can be
across
in
clouds.
cloud
Okay.
and another one can be
All
another one.
right,
Yes.
perfect. Right. So you can like in literally one click, I was going to say a few clicks, one click, pretty impressively spin up the right infrastructure. And then here, it looks like you're pretty agnostic to also agent frameworks.
Correct. That's
So
very, very good. We are not an agent framework. We are a
yeah,
runtime.
because I see it represented here. I'm like, okay, so it could be a custom one, it could be LangChain, it could be Google ADK, it could be Crew, it could be
Yep.
AutoGen, like
Here's OpenAI agents, just putting a
OpenAI
couple.
SDK. Yeah.
Yep. You can use LangChain. Here's a LangChain example that we just took, which is multi-agent trader example. I have them running. You can simply write it. And we didn't change anything. We just took it as is and applied a couple decorators to it.
Yeah.
And you get not only the observability, the robustness, and the error handling, but also a fan out and zero usage of resources when you don't need it. It just goes away. Full auto scale.
And so I mean, you're taking observability, like there's traces in there with your decorator, but then you're saying, wait a minute, because a lot of the observability software solutions today do not provide this extra layer of failure handling, scaling up, like memory. Like I haven't seen this. Like this is pretty impressive.
Yeah, so observability is a byproduct of doing the right thing here, which is orchestrating the pieces. And when you orchestrate the pieces, because we are a compute fabric, we exactly know what you were doing. How long did you run for? Like we can tell you that you were running for this thing ran for like 1 second. while this thing ran for like 4 minutes, and it was getting throttled by your GPU provider, right? Like those things you can just tell. You don't even have to actually go for SLMs, and this is where we see the world going. Why did we build this platform? We were doing ML. People are using this to train Dream Machine model. Odyssey ML uses it to train massive models. LLMs are being trained on this platform on their own. All of, if you're using jobs you may need on LinkedIn, those encoding models as well as the recommendation models are trained on this platform, including Autopilot by Tesla. Like they are training on this platform. That's where we come from. Our heritage is ML research and ML scale. But we realized AI agents are not different from ML. It is like we have to accept it. It is
Oh, we
not
agree.
like
We
building
agree.
regular software. So once you accept it, you're going to be like, I need a platform like this that versions, that scales, that manages things, and allows four of my developers to share their code without really sharing, reuse things, and test independently. I don't want to like, hey, I changed this one MCP server, now every other agent's broken. That's not okay. So we need a way to do this in an isolated way, and that's our vision. That's what we saw. And you hit my last point over here is that we are not a 101st agent framework. That's not our goal. Bring your agent frameworks. We are what we call an agent runtime.
Thank you so
Okay,
much, Ketan. This was
that's it.
a
Thank you for
great
sharing.
demo presentation. Appreciate it.
Yeah, and please ping us. You can join us for our beta for this new platform. It's built on the foundations of a strong open source platform, and we are here to help. We serve models, we train models, and we